You know what really makes a software system great? I mean, truly great? It's not about using the newest, shiniest framework or the trendiest language out there. Nope. It's about a set of timeless principles. These universal rules that decide if what you're building is actually going to last. So, let's dive in and uncover what they are.
All right, let's just jump right in with a huge question. If you had to pick just one thing, one single most important rule in all of software design, what would you say it is? You might think it's about making things fast or keeping it simple, but what if I told you it's something else entirely?
And here it is. This is the big one, the first law of software architecture. This one sentence, it's the bedrock for literally everything else we're going to talk about. It's a simple and, yeah, sometimes kind of frustrating truth. In software, there are no perfect answers. None. There are just choices, and every single choice you make has a consequence.
Okay, so let's dig into what this law really means when the rubber hits the road. Everything's a trade-off is easy to say, right? But really getting it, I mean, deep down, that's what separates the good architects from the truly great ones.
And get this isn't just some nice-sounding advice. It's a challenge. It means that if you're looking at a solution and thinking, wow, this is perfect, no downsides, well, you're probably wrong. You just haven't found the hidden cost yet. And finding that cost, that's the job.
Here's a perfect real-world example to chew on. Imagine you're building an auction system. A bid comes in. Now what do? Do you send it directly to all the different services that need it using separate, dedicated queues? That's simple, sure, but it's also pretty rigid. Or do you just broadcast that bid out on a single topic for anyone to listen to? That's way more flexible, but it's also a heck of a lot more complex to manage. See? There's no right answer here. There's only the least bad answer for what you need right now. All right, so if every decision we make creates these complex trade-offs, how on earth are we supposed to manage all that chaos? Well, the answer is a beautiful concept called modularity. It's basically the art of taking a giant, scary system and breaking it down into smaller, bite-sized pieces we can actually understand. And this is what happens when you get it wrong. Take a good look. This lovely mess is what we call a big ball of mud. It's the ultimate anti-pattern, a system where there's no real structure, everything is just tangled together in a giant knot. You try to change one little thing over here, and something completely unrelated breaks over there. It is, without a doubt, an architect's absolute worst nightmare.
So how do we stay away from that nightmare scenario? The first big idea you need to grasp is cohesion. The best way to think about it is like a well-organized kitchen drawer, you know? All the forks are in one spot, all the spoons in another. Everything in a single compartment just belongs together. A software module with high cohesion is exactly like that. It has one job, and all the code inside it is focused on doing that one job really well.
Now, the other side of that coin is coupling. This is all about how tangled up different modules are with each other. Imagine if to change the tires on your car, you also had to mess with the radio's wiring. That would be insane, right? We'd call that tightly coupled. And in software, that's incredibly dangerous because it means a tiny change in one part of the system can cause a chain reaction and break something you didn't even know was connected.
So this all leads us to the absolute golden rule of modular design. You want high cohesion and low coupling. It's that simple. On the inside, your components should be focused and self-contained, just like that organized drawer, and on the outside, they should connect to other components using simple, predictable interfaces. Think of it like a standard electrical outlet. You just plug things in. When you build like this, your whole system becomes so much easier to understand, to test, and most importantly, to change later on.
But here's the thing. Even if you master modularity, there's a bigger, scarier problem lurking in the shadows. How in the world do you design something today for problems you don't even know exist yet? How do you plan for a future that's a complete mystery?
This famous, or maybe infamous, quote really nails it. It perfectly captures the single biggest threat to any software project. See, it's not the problems you know about, or even the things you know you don't know. The real danger is the unknown unknowns, the stuff you're not even aware you should be worried about. These are the things that completely blindside you and can sink a project. And look at this pyramid. This really drives the point home. Everything you're confident about, the known knowns, that's just the tiny little tip of the iceberg. The vast, vast majority of any project, the real meat of it, is that massive base layer. That's the stuff you don't even have the vocabulary to ask questions about yet. That's where the real risk is.
And this is exactly why the old school approach of big design up front, almost always runs into trouble. Trying to map out every single detail of a system for the next 3 years is just impossible. It's like trying to draw a perfect street-level map of a city you've never even heard of. You're guaranteed to get it wrong because you can't possibly account for all those unknown unknowns.
Okay, so if we can't just plan everything out from the start, what do? How do we keep our systems from slowly falling apart over time? Well, we need a way to make good decisions as we go. And maybe even more importantly, we need a way to make sure people actually stick to those decisions. And that's where something called architectural governance comes in.
Because, let's be real, it's great to have these lofty principles like low coupling, but what happens when a developer is facing a crazy deadline? It's so tempting to just create a quick, hacky connection to get the job done, even if it violates the rule. If you don't have a way to enforce these principles, they just become nice suggestions that nobody follows.
So one really powerful but simple tool for this is something called an ADR, an Architecture Decision Record. Now this isn't just your boring old meeting notes. An ADR is a specific document that captures not just what you decided, but the why behind it. It explains the problem you were facing, the actual choice you made, and this is the most important part, the consequences, the trade-offs you knowingly accepted. It's like a time capsule for future developers so they can understand your thinking.
But we can actually take this a step further than just writing things down. Enter the architectural fitness function. It sounds fancy, but the idea is pretty simple. It's an automated way to check if you're still following your own rules. Think of it like a unit test, but instead of testing a small piece of code, it's testing a characteristic of your entire architecture. It's a little piece of code that runs and tells you, hey, are we still as fast as we need to be? Or did someone just create a forbidden dependency?
And probably the most famous and wildest example of this is Netflix's Chaos Monkey. Its job is to test one thing, resilience. And how does it do that? Oh, just by randomly shutting down servers in the live production environment, for real. It is the ultimate fitness function because it automatically and constantly enforces the architectural rule that says our system absolutely must survive any single component failing at any time. Okay, so this kind of brings us all the way back to the beginning. If everything is a trade-off and we can't possibly know the future, then what are we even trying to do here? What's the goal? Well, here's a spoiler. It's not about finding the best or perfect architecture. It's about something way more realistic.
Just think about this classic dilemma. You want to make your system more secure, right? So you add more encryption, more validation checks. What's the inevitable result? Yep, it slows down. Performance takes a hit. You literally cannot have maximum security and maximum performance. They are opposing forces. Pushing one of them to the absolute limit will always, always hurt the other. You have to pick your priority.
And there is a perfect cautionary tale for this from history. Ever hear of the Vasa? It was this massive Swedish warship from the 1600s. It was designed to be the absolute best at everything. It had 2 full gun decks instead of the usual one, packed with extra-large cannons. It was going to be unstoppable. The result? It was so ridiculously top-heavy that on its very first trip out of the harbor, a small gust of wind came along, and it just tipped over and sank, right there, in front of everyone.
And that story brings us to the most important takeaway of all. This is the whole philosophy in a nutshell. Never, ever try to build the best architecture. Instead, aim for the least worst architecture. Your job isn't to build a flawless masterpiece like the Vasa was supposed to be. That just leads to disaster. Your job is to understand all the messy trade-offs and pick the combination that is the least bad for the specific problem you have today.
So, I'm going to leave you with a question to chew on. Think about the project you're working on right now. What trade-offs have already been baked into its design? And here's the kicker. Which ones are you living with every single day without even realizing they were a choice? Because finding those hidden trade-offs, that's the real first step to making things better.